Right, in this video we're going to be going over two inequalities which are relatively easy to prove. We have that for a complex number, z, equaling x plus iy, and equivalently you can write this as the real part of z plus I times the imaginary part of z. X is the real part and y is the imaginary part. So the inequality we're going to be proving is that the modulus of the real part of z is less than or equal to the modulus of z, and the same can be said for the imaginary part of z. Okay, so remember that the modulus means, so for instance, the modulus of z is going to be the square root of x squared plus y squared. The square root of the real part squared and the imaginary part squared. So the real part is just going to be modulus of x, which is going to be equal to the square root of x squared, and it's quite easy to see that this is going to be less than the square root of x squared plus y squared, which is equal to the modulus of z. To make that even clearer, we can square both sides of this, and we're allowed to do that because both sides of the inequality are positive. If we square both sides, we get that x squared is less than x squared plus y squared, less than or equal to, which is obviously true because this y squared will always be positive. And so that proves this, and the proof for the imaginary part is awfully similar. The imaginary part is just y. So the modulus of the imaginary part of z is equal to the modulus of y, which is just the square root of y squared, which is less than the square root of x squared plus y squared, which is the modulus of z. And using the same thing with squaring both sides illustrates this inequality even clearer. So like I said, quite straightforward. Any questions on this or any videos on complex analysis you'd like me to do, please indicate that in the comments below. And thanks for watching.